Okay, Wildcats. Today we're looking at Monday, February 4th, cube and cube root transformations on page 50. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, cubic transformations on page 50. F of x equals negative a, parentheses, negative bx minus h cubed plus k. The negative in front of the a reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative in front of the b inside the parentheses, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. And when it's minus k, it translates down. I would update the cubic transformation notes. All right, now let's take a look at cube root transformations on page 50. When f of x equals negative a times the cube root of negative bx minus h plus k. When the negative in front of the a reflects over the x-axis, when a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative in front of the b inside the cube root, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. When it's minus k, it translates down. I would update your notes. All right, you have your cube root transformation notes. Let's take a look at the examples. All right, now before we do example 1 and example 2, these are both cubic functions. We need to look at the cubic parent function, okay? So f of x equals x cubed. So when x is negative 2, then that is negative 2 cubed, which is negative 8. When x is negative 1, that's negative 1 cubed, which equals negative 1. When x is 0, that's 0 cubed, which equals 0. When x is 1, that's 1 cubed equals 1. And when x is 2, that's 2 cubed equals 8. All right, now we're going to use this because these are the directions for the cube function, okay, cubic function. All right, so here we know the name is cubic. We're now going to graph with direction and using these directions right here, okay? We don't need to write the 0, 0 because that's going to be the vertex, which we know is the minus 1 moves it right 1, and the minus 1 here moves it down 1, so our vertex is right here. Okay, so using the directions that we got from here, okay, we can now graph. So we go left 2 down 1, 2, 3, 4, 5, 6, 7, 8. Left 1 down 1. To the right 1 up 1. And these directions are based on the new vertex. Okay, to the right 2 up 1, 2, 3, 4, 5, 6, 7, 8. Now, the domain and range for a cubic function are really simple. It's negative infinity to positive infinity and negative infinity to positive infinity. Okay, let's do the transformations from right to left. So the first one is right 1 unit. And down 1 unit. Ooh. Got a little blurry there. There we go, out of blurriness. All right, so here, name's real simple. It's a cubic function. Okay, we need to move the vertex. So the plus 1's to the left 1, and then up 2. Again, we're going to graph by direction. Again, using the same directions, -2, -8, -1, -1, 1, 1, 2, 8. But here we have to multiply by -1. So that becomes +8, +1, -1, -8. So from the vertex, new vertex, we go left 2, up 1, 2, 3, 4, 5, 6, 7, 8. Left 1, up 1, right 1, down 1, and right 2, down 1, 2, 3, 4, 5, 6, 7, 8. Okay, domain and range, again, real simple, -infinity to +infinity. And transformations, again, starting from left to right. So the first one is reflect x-axis. Next one is left 1 unit. And last one is up 2 units. All right. Now that was the cube functions. Now let's move into the cube root functions. And again, before we do that, we need to look at the cube root parent function. Okay. So using the same x value, so when x is -2, actually, no, I'm sorry. The cube root function, we want to use -8, -1, h is 0, and I should have put that here. H is 0, and 0 is k. Okay, so +1 and +8. All right, so the cube root of -8 is -2. The cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1, and the cube root of 8 is 2. Now, keep in mind, we're going to use these points for our directions and our transformations, okay? So name cube root. We need to move the vertex. So the +3 means left 3 and then down 1. All right, now we move the vertex. We need to graph by direction. Remember, using these values right here for our direction. So -8. Don't need to worry about the vertex. So -8, -2, -1, 1, 2. But here we have to multiply by 2. So that's -4, -2, 2, 4. So from here we go left 1, 2, 3, 4, 5, 6, 7, 8. 8's off the graph a little bit. And then we go down 4. So 1, 2, 3, 4. Okay, and then left 1, down 2. To the right 1, up 2. And to the right 1, 2, 3, 4, 5, 6, 7, 8. Up 1, 2, 3, 4. Now, domain and range, again, are real simple. -infinity to +infinity, and -infinity to +infinity. Sorry, the sun's gone down, so I need to open the blinds and adjust the camera a little bit. All right, so now let's go through the transformations. Again, we're going to go from left to right. So it's a vertical stretch of 2, left 3 units, and down 1 unit. All right, let's take a look at example 4. Okay, name, again, real simple, is cube root. We need a graph by direction. Again, using -8, -1, 1, 8, -2, -1, 1, 2. But here we have to multiply by -3. So that's +6, +3, -3, and -6. So let's move the vertex. So we go right 1, up 2. And then we go left 1, 2, 3, 4, 5, 6, 7, 8, up 1, 2, 3, 4, 5, 6. And then we go left 1, up 1, 2, 3. Then to the right 1, down 1, 2, 3. And then to the right 1, 2, 3, 4, 5, 6, 7, 8. Down 1, 2, 3, 4, 5, 6. Okay, domain and range are real simple. -infinity to +infinity and -infinity to +infinity. Transformation reflects x-axis, vertical stretch of 3, right 1 unit, and down, not down, up 2 units. All right, so if you would finish up example 3 and 4. All right, now going to tape these into the page. So I'm going to put the cube root one first. Line it up right there. All right, then I'm going to flip that up. And then I'm going to come here for the cube root. I'm going to tape it right there. Let me flip that up. I think I put too much tape on it. So I can, I don't know. Guess I'm going to have to cut that. So don't make the mistake I made. I have to cut some of this tape off. Here and here. I apologize. I know this is adding seconds to the video. I'm probably like really, really angry. So again, I apologize. All right. There you go. Some time of your life wasted that I'm so very, very sorry for wasting, but now we move on. All right. Example 6 and 7. Graph the cube root inequalities using transformation. So we graph by direction. Now for cube, we know that the directions are -2, -8, -1, -1, HK, 1, 1, 2, 8. Okay, so we first move the vertex, which is just down 1. Okay, and now we go left 2, down 1, 2, 3, 4, 5, 6, 7, 8. And now we go left 1, down 1, right 1, up 1, right 2, up 1, 2, 3, 4, 5, 6, 7, 8. There's no line underneath, so it's a dashed line. And it's greater than, so we shade above. All right, so finish up example 6. All right, so now let's take a look at example 7, graph by direction. All right, so we know our directions are -8, -2, -1, -1, HK, 1, 1, 8, 2. And so for the vertex, in this case, we move to 1, 2, 3. And then we go left 1, 2, 3, 4, 5, 6, 7, 8, down 2. Left 1, down 1. Right 1, up 1. Right 1, 2, 3, 4, 5, 6, 7, 8, up 2. Now, there's a line underneath, so this is a solid line. And then it's less than, so we shade below. All right, so if you would finish up your examples, start working on your assignment, and have a wonderful Wildcat day.